Hey guys, welcome to your first Science Notes video. I'm Miss Healy. Let's get started. Here's a few things to help you be successful when you take video notes. Remember to watch the video twice, once for the notes and once to catch extra information that we might say but not have written down. Make sure you take your notes using the C Notes format and take them in your science notebook. Remember that you can pause this video at any time to take your notes, so don't feel rushed. There will usually be a video check the day after notes are due, and you usually only get 1 day to complete your notes, so try and keep up. If there are drawings or diagrams that we want you to draw, we'll tell you, and make sure that you always write everything down. So let's talk about force. If you remember, a force is just a push or a pull, and a force has a direction that it goes and an amount. So an example would be the force is going to the right, or the force is going to the left, or that force was 10 newtons. The one force that is the basic force in all of the universe is gravity. It attracts all objects to each other. So when you measure the length of your textbook, you have a tool you use. You would use a ruler. Well, when you measure force, you have a rule. We use what's called a spring scale. And the unit for force will always be a newton. And you can see how many newtons something is by looking right here or right here. And these are two different examples of spring scales we use in class. So we know the basics of what a force is, so let's talk about what the basics of work is. Well, first of all, remember with some words you can have a normal definition that you're used to, and you can have a science definition. So for work, you might say, man, dishes sure is a lot of work, or man, school was a lot of work, like this. But that's not the science definition. The science definition is when a force of an object over a distance is in the same direction of the force, like this. So when you push something and it moves and it goes into a direction, that's the science definition of work. So let's focus on the scientific definition a little more. So if work is being done, the object has to move. If it stands still, there's no work. So it has to move a distance, and the distance has to be in the same direction of the force, just like in this little purple picture. So in this scenario, work is in progress. But with no work, the object is not moving, even though you push on it. So in the example I have in red, the little guy is pushing the building, but the building's not moving, so there's no work. Now, what if you push on something and it pushes back at you? That's still no work because your force and your direction weren't in the same direction. So, no work happening there. So, let's calculate some work. To calculate work, you have to know what the formula is. And the formula is work equals force times distance. The units, when we measure work, it's in joules. Force is in newtons. And distance with a work problem is usually in meters. So our example in blue is, if the force is 3 newtons and the object moves 2 meters, then how much work is being done? Well, force equals 3 and distance equals 2. And since work equals force times distance, work equals 3 times 2. So work equals 6. And don't worry, we're going to do a lot of this in class. So a lot of times when we talk about scientific work, we talk about, well, how can a simple machine like a ramp, an inclined plane, affect work? Believe it or not, a ramp does not reduce the amount of work you do, even though it feels like it makes it easier. It's easier because ramps increase the distance, which means we won't need as much force to push the object. So your amount of work stays the same. We will do a lab over this, so for right now, trust me. Now, I just threw a lot of information at you, but don't worry. Everything I told you about today, we're going to go over in class. You just need to make sure that you watch this video at least twice and you write everything down. Also, make sure you go back and draw out those 2 stick figure examples. Can't wait to see you again. Have a great day.